Okay, this is the Math 11, Math 1401 Zoom meeting for Thursday, February 9th. My apologies, February 11th. And so we'll start in just by working some a few problems. We're doing sections 3.4 and 3.5 this week, and test 2 tomorrow. 3.1, 2, 4, and 5, and it is proctored through E2L. Same format as the other tests. Watch for instructions. All right. Why don't we some of these things are really long, so I'm not going to copy them down. Get it straightened up here. Oh, we have a participant, Miss Wisby. I was just about to charge into working some problems when I noticed you. You're showing muted on my screen. So did you have any questions today? Now you don't seem muted.
Okay. Well, my question was about, you said the lockdown that you could add, there was a sample quiz or something to make sure lockdown was set up correctly.
Right.
When I went into sample quiz, there was not, the only thing that was in there was the discussion question from the first week or something.
Did you get my email of a couple of hours ago now where I found that I had not clicked? I discovered that quiz was hidden.
Okay.
And I sent around an email and I figured out where to click to unhide it, make it visible. And so, yeah, I told everybody to try it again.
Okay. No,
Yeah,
I see it now, but I'm just not opening it.
Okay. It's not opening for you?
Well, let me try to go into D2L and just see.
Okay. Can I go ahead and work problem 9 here while you're doing that, and then you can come back to me?
Okay, yeah, and it's in here now. Thank you. Yes,
Oh.
I'll do that. Yeah.
Okay. Yeah, that's on me. That's what drives me nuts about D2L. There seems to be some hidden button that I always miss to make things work through it.
Okay.
And so, yeah, you weren't the only one who had trouble. I got several emails about it, so I checked into it, and that's what I discovered.
Okay.
Okay, is there any problem you would like to see?
Let me get back to Zoom. I'm sorry. No, not right now. I think what I'm gonna do is I'm gonna be on again at 8. You have another call today at 8, right? Another Zoom.
At 8 tonight, yes.
Yeah.
Okay, so you're going to want to ask your questions then?
Yeah.
Okay. Well, feel free to hang around then. I'll just pick a few out of each section and go ahead and work them here. All right, so for 3.4, we're on page 154. Let's try number 9. And yeah, these things are very long, got a lot of data in them, so I'm not going to waste the next 10 minutes copying this. I'll just sort of, and the Wi-Fi's got a little bit of delay today.
Yeah, and I see your reply to the notes and everything and formulas, so I didn't know what to expect with this proctored exam, so thanks for answering that.
Okay, yeah, it's going to be the exact same format.
Okay,
The only thing, in other words, on the Google form, I'm going to send around a test form, some problems correct, some problems incorrect. That'll be separate, outside D2L. There's no way to do it inside D2L. I've checked and checked on that. That will be
okay.
sent to you via email outside D2L.
Mm-hmm.
The actual test will look like a Google form. It'll be my best approximation to a Google form. All the problems will
Okay,
read. Number one, true or false, the problem is correct. Number two, true or false, the problem is correct, etc.
okay, okay,
So the actual test, yeah, will be done inside that D2L. It'll read test two inside D2L. Now, the only difference is you won't type the true or false like on the Google form. I can't really tell what you do. I think you may be able to click on the words true or false with a mouse.
oh, okay. So well, in the Google form, we type it in with a capital T or F
Right.
and write it out. So type it out. So
Yeah, I don't think you do that inside D2L. My
okay,
impression is you click on the words true or false.
okay, okay,
All right, so when you've answered all there should be 20 questions, true or false, inside D2L, then you submit the test. You won't get your grade immediately, just like the first test. I'll have an absolute deadline probably next Wednesday, midnight, beyond which I will not check any more responses. And
okay.
then I will get on D2L, record the grades, and mail out the reports.
All right. Okay.
And that is the only one we will do this way, and I'm just doing it for a school requirement.
All right.
We will go back to the Google Forms for the rest of the tests and for the final exam. Okay, a problem like number 9 here. They want you to compare two situations of Z-scores and decide again, I guess, who is the better, which player had the better year. So they give you, I don't know if you know these people from baseball. This is getting old, like 7 years ago now. I think Clayton Kershaw still plays. He had the lowest ERA. This is the average or mean number of runs yielded per 9 innings. It's a measure of how good a pitcher is. And he had an ERA of 1.77. So on the average, people only scored 1.77 runs against him for 9 innings when he was pitching. Then they compare this guy, Felix Hernandez, in the American League, and he had the best ERA or lowest, 2.14 in the American League. Now they give you the statistics, the mean, these, they don't tell you this, but these are the X numbers because they're specific to these different people. All right, then the average ERA for all pitchers in the National League was 3.43 and standard deviation 0.721. In the American League, average ERA, mean ERA was 3.598, standard deviation 0.762. Who had the better year relative to his peers? So this is supposed to be similar to the baby problem that I showed in the video. I'll write the numbers down for each of these people, and then it's plug and chug into the Z-score formula. So we'll have Clayton Kershaw, and his X was 1.77. The mean for him further down was 3.43, standard deviation 0.721. All right, that's situation 1. The other guy was Felix Hernandez. His X was 2.14. And the mean there was 3.598, standard deviation of 0.762. So if you just compare the raw X's, it looks like Clayton Kershaw was better than Felix Hernandez. But to really decide, you have to bring in these means and standard deviations, because that will tell you, how much better his peers did on the other teams and et cetera. And that's really what you got to bring in. All right, so if you remember your z-score formula, we'll call this number one, this number two, I guess. Number one, x minus mean divided by standard deviation. So 1.77 subtract 3.43 divided by 0.721. Let's see if I can get both of them up. Oh, we're getting a little less delay here. Things are working better. Minus 3.43, 0.721, negative 2.30, call it. So you understand what that means? I don't know if are you still here? Oh, okay. Yeah, that means he's 2.3 standard deviations below his mean. All right, number two, we'd have 2.14 subtract 3.598, 0.762. 2.14 subtract 3.598 divided by 762, negative 1.91. Negative 1.91 standard deviations below mean. Below mean. He is 2.3 standard deviations below mean. Mean, you'd come to negative 1.91 before you'd come to negative 2.3. Who had the better year? Well, I hope you know about baseball. This is an example of knowing the underlying subject. You would want to be as low as possible with this for a pitcher to be considered good, and so that would be Clayton Kershaw. All right, that's an example from 3-4. Well, there's other thing. We did two other things in 3-4. Next thing we did was problem 15. Yeah, Wi-Fi is working much better, much less delay here. 15 part B. Percentiles. 90th percentile of waist. That's W-A-I-S-T, around their waist, their middle circumference. Of females 2 years of age, 52.7 centimeters. Explain. So we would say 90% of waist circumference of females. Yes, okay. 2 years of age is lower than, less than 52.7 centimeters. So at 52.7 centimeters, you're in the top 10% of waist circumference. Remember, in pictures like this, you don't say equals. 52.7 and 90% of the waist circumference would be lower than or less than. You think of another way to say it. Do not say equals. Okay, that's not what it is. 90% are not equal to 52.7. That's not it. You'd have 90% people running around exactly 52.7. That's not it. All right, let's try the next thing in 3-4. Let's try, 21 kind of puts it all together. 21 is data about smart cars. It's at the bottom of the page here. And then all the data is over here, and it kind of puts everything together. And then you've got several others like it. The data's pretty reasonable. It won't take too long to enter this data. So this starts on page 155. 21, data for smart cars. I won't write the data here. In part A, compute z-score for an individual with 36.3. We'll just say X equals 36.3 mpg. All right, well, we've got to find our mean and standard deviation. I'll use the X because the calculator does. So we're going to punch in TI-84. Data into TI-84. All right, if I can get the book over here and then punch the data in. All right, so these are miles per gallon for smart cars. Clear down. Okay. 31.5. You can do it in any, you can go across, you can go down the columns. It's up to you. 35.5. Okay, 36. 36.3. 37.4. I'm getting the feeling these were put in order down the columns and moving left to right. Getting the feeling of that. All right, 37.1 and then 37.5. Okay, there's two columns. 8. Yeah, the numbers seem to be gradually increasing. 8 and 38.3. 3 columns in. 4, 38.8, 39.3, 5. Okay, there's 4 columns in. 6, 4, 5, 42.3, 7, 43.5, and 47.5. Okay, that should be 24 numbers. 6 columns, 4 each, 24 numbers, yeah. All right, stat, calc, variable stats, enter. Mean of 38.775. Standard deviation, you can use the SX if you want. 3.4165. You can keep less, 4.2. Maybe I'll use 3.42. You don't have to keep that many digits. So now, z-score equals 36.3. That's your X minus your mean divided by your standard deviation. Okay, if I keep both up, 36.3, subtract 5 divided by 3.42. Negative 0.72. Usually keep 2 digits on a z-score. We'll explain why in chapter 7, 0.72. This car, x equals 36.3. This car is 0.72 standard deviations below the mean. So he's below average, not quite to 1 standard deviation below mean. That's part A. So yeah, a bit of a project because they not kind to you, didn't give you the standard deviation or the mean. You have to know to plug in and find them. All right, B, quartiles. That would be Q1, Q2, and that's median, and Q3. Well, we can go to the second page. I have to repunch the data in. Calc, enter, okay, second page, 36.85. Median, Q2, 38.35. Q3 is 41 even. It tells you what those are. C, find QR, interquartile range. Hope everybody remembers from Monday. That's the difference of Q3 and Q1. 41 minus 36.85. 4.15. Barely got on the page. And finally, we go too fast. Upper and lower fences. Lower and upper fences. D. Lower fence. Hope you remember from Monday, that is Q1 subtract 1.5 times the IQR. So that makes 36. Get them both on the screen. You see the numbers you need, 36.85, subtract 1.5 times 4.15. $30.625. UF, upper fence. Q3 and add 1.5 times the IQR. 41, add 1.5 times 4.15. 47.225. So the last question, are there any outliers? Oh, we have a participant. Okay, let me finish this and we'll get to you. Just now noticed you. All right, so I'll just put the fences on. So at 47.225, your upper fence, and your lower fence was 30.625. And so we're looking for any numbers greater than this, less than the upper fence or greater than, less than the lower fence or greater than the upper fence. Looking at the data, there's no number below 30.625. So we've got no outliers, but look at the 47.5. Yeah. 47.5 here is bigger than the upper fence. So the answer is yes. 47.5, it is greater than 47.225, the upper fence. So the lucky person who bought that smart car Got a really large gas mileage, got a lot of gas mileage. Okay, we have a participant. Can we, do you want to ask any questions before I work this? That's pretty much everything from 3.4. You want to ask anything before I go on to 3.5? Your mic is muted. It's showing muted. So if you're talking to me, I can't hear you. Yeah.
No, please.
Okay. Did you have a question?
No, please.
No? Okay. You want me to just go on and work an example from 3.5?
Yes, please.
Okay. .5 is your 5-number summary. And a box plot. Just to sketch out again what a box plot was. You left side of the box is Q1. You put a line in the middle. That's your Q2 or your median. Same thing. Q3 on the right side of the box. They'll put an upper fence out here. Lower fence. And the whiskers. This is sort of a box and whisker plot, they call it. All right, this goes to the highest data value inside the fence, or lower than the upper fence. Book uses lower than the upper fence, inside the fence. And this goes to the lowest data value inside the fence, or greater than this lower fence. Star any outliers. That way, outlier. That's the best summary I can get of a box whisker plot of all the other directions. Okay, if we try an example. I've got a lot of data here. Why don't we do problem 11? The age of a mother at birth. So here's the data. Construct a box plot. I'll write down the 5-number summary too, because they asked for it in problem 9, just to remind everybody what the 5-number summary was. Do a box plot and then describe the shape. I won't write the numbers down here. Okay, this is page 163. Problem 11A, box plot. Stat, edit. We got 21. I'm going down the columns, 30, 18, 17, 35, 24, 20, 24, 23, 33, 16, 20, 33, 25. That's 3 columns in. Yep, 15 numbers. 3 more to go. 2, enter, 29, enter, 22, enter, 29. That's 4th column. 22, 25, 21. I know this isn't really exciting for y'all, but it's the only way to really do it. Okay, so that's the 5th column. Yeah, there should be 6 columns. See, there's 5 numbers, each column, 2, 3, 4, 5, 6 columns. So there's 30 numbers. There's 5 more to go, last column. 26, 20, 19, 25, 19. Yep, looking for the 31st number, but there isn't one. There's only 30 numbers. Now what we need off of this, we got to find the median and the quartiles. Let me do the 5-number summary, even though I didn't ask for it. Just to remind everybody, that was min, Q1, Q2 median, Q3 max. So I go to stat, calc, one variable stats, enter, 24.07, I'll call it. That's the mean. I don't need to write that down, actually. I need the median at the center of your box plot. So the 5-number summary is 16, Q1 is 20, median's 23.5, Q3 is 26, max is 35. If they ever ask for it, that's the, it's all on this page, given in the same order the book asks for it. All right, your box plot. Q1, that would be your 20. Median, 23.5, Q2, 23.5, or median. Q3, 26. Okay, let's see. We need the fences. Lower fence, upper fence. All right, lower fence. I don't know if I need to rewrite the thing. Well, maybe I will. Code Q1, subtract 1.5 times IQR. I haven't asked for the IQR separately, so I'll just do it all at once. So that's 20, subtract 1.5. IQR is 26, subtract 20. You can do that in your head. That's 6. So the lower fence is going to be 20. 1.5 times 6. That's 11. Lower fence is 11. 11-year-old's given birth, so probably won't have any outliers in this case. Upper fence. Q3, add 1.5 times IQR. That makes 26. Add 1.5. Again, I'll write it's 26 minus 20, which is 6. More delay on the Wi-Fi. Let's see. 26, add 1.5 times 6. 35. The upper fence is 35. Now I'm going to do the box plot very anally. Here, I've still got it here. The whisker goes to the highest value that's inside the fence. Let's see, my highest from the 5 numbers, some of the highest. Well, okay, in actuality, that's going to be 35. So this is a case, this whisker is going to run right out to the fence. Okay, but this one isn't. The minimum is 16. So this one is going to run to 16. That's the lowest data value. You can see lowest data value that's inside the fence. Outliers. Anybody greater than 35? 35 was said to be the max. So yeah, it's in there. Nope, nobody bigger than 35 and nobody smaller than 11. So there are no outliers. Questions about that? Part B was to describe shape. So I would take, this is to say the right side, call it RS, compare it to the left side. So the right side is 35 minus 23.5. We go to the next page. 3.5. 11.5. Left side, you can still see that, That would take 23.5, subtract 11. $12.5. Well, this would say it's slightly skewed left. My book is saying slightly skewed right. I wonder if they're using just the box. 26 minus 23.5 would be what, 2.5 here, and this side would be 3.5. That's still saying skewed left. Huh. I guess I would compare mean and median. What was the mean? Maybe that's what they're doing. The mean was 24.07. And your median was 23 point. Okay, so this is where they're getting their skewed right. You know, you could kind of, this is an art. If you use this argument instead of slightly skewed left, I wouldn't argue with it or mark it wrong. They're using apparently this and calling it skewed right. This is what the book is doing. That pretty much finishes 3-5. We're at 40 minutes on the Zoom meeting. Did you have anything else you wanted to ask about before we call an end?
Yes, please.
Yes.
Looking at the equation, to determine the skew right, did you look at the lowest number, like 11.5? From part B.
I looked from the upper fence back to the middle.
Okay.
That's where I got 35 minus 23.5. There really is no single correct way to do it.
Okay, thank you.
Okay, so that gave me 11.5, and then I look from the center back to the lower fence. See, I don't do it this way because I don't want it to come out negative. I don't want to go 11 minus 23.5.
Okay.
So I go from 23.5 minus 11, and I got a little bigger, and so that signals to me kind of skewed left. But I checked the answer in the book, and the book is calling it skewed right. The only way I can figure they're doing that is they're comparing it the mean to the median.
Okay, thank you so much.
Yeah. Is there anything else you want to ask before we end the meeting?
No, please.
Okay, we'll have one more session tonight at 8 o'clock if you want to come out, if you have more questions and want to ask tonight.
I will.
Okay, we'll look forward to it. Otherwise, we'll end the meeting. Thank you for coming out.
Thank you so much.
Uh-huh.